Hey everyone, we're looking at Big Ideas 2.2 in this lesson. It's the characteristics of quadratic functions. So in the last lesson we were looking kind of more specifically at the vertex form of the quadratic function. You can kind of see it here as far as this is f of x equals a, and then you get the parenthesis x minus h squared plus k. But we're going to be looking at two other forms as well, standard form and intercept form in this lesson. And the characteristics, we'll see some properties of parabolas, maximum, minimum values, and things like that. Alright, before we get there, let's go ahead and just look at a little video. So here's a far side video. Guy with the paint there. Now, that should clear up a few things around here. So he's labeling everything around. This has labels the cat, labels the dog, the tree. Alright, well, as we go into our vocabulary, page 31, you want to take a look right there and see it says axis of symmetry. So you know what a quadratic function looks like on the graph. It's the parabola, the U-shaped graph here. And so the axis of symmetry would be a straight vertical line going right through the center, cutting this parabola into two equal halves. So you want to write down it's a line that divides a parabola into mirror images and passes through the vertex. And you can also write down that it is the vertical line x equals h. So it's the line, the actual equation for that line would be x equals, because it is a vertical line. We learned about vertical lines before. X equals the number of the h coordinate right there. So whatever your h coordinate is, whatever that number is, that would be the number here for the axis of symmetry line going down. It's still on page 31, the vocabulary word standard form. So that is another form of a quadratic, and this would be what it is. You can just write this down where it's a standard form. F of x equals a x squared plus bx plus c, and it's kind of where you could see an a, b, and c. We'll talk about a, b, c as we go through quadratic functions and going through solving quadratic equations. But these are just always numbers. A, b, and c would be numbers in your equation. So a would be the number in front of your x squared. There's the core concept there as well, the properties of a graph that's in this form here. So it's showing you a couple different ones here. It says the parabola on these bullet points down here. The parabola opens up when the a number, when the number that's in front of the x squared, when that's greater than 0, and opens down when it's less than 0. So what that's going to be referring to is a reflection. So because you can see there, you have this one opening up and this one's opening down. So that's a reflection over the x-axis in that case. So when it does open up, that's when the a is greater than 0, which would be when the a number is positive. And when it opens down, that's when the a number is less than 0, so that means the a number would be negative. So we know that. We know that when the a number, when there's a negative up in front here, and that a is negative, that's going to cause a reflection. It's going to open down. But it will open up when it's positive. This next one says the graph is narrower than the graph of the parent function. Remember, we know this is the parent function, f of x equals just x squared, when the absolute value of a is greater than 1, and it's wider when the absolute value of a is less than 1. So that would be not worrying about whether the a is positive or negative, but just looking at the number of a. When that number is greater than 1, it gets wider. When it's less than 1, narrower. Well, that would be the transformations of stretching and shrinking the graph, which we've seen before as well. So the as it gets narrower, you might want to highlight some of those. It's narrower there or wider. So we know when it's narrower, it's going to be stretching it. When it's greater than 1, when it's wider, it's going to be shrinking it, getting closer to the x-axis down here as it widens that graph out, flattens it out. Down here it says the axis of symmetry. We just talked about that is x equals negative b over 2a. So that's a little formula to find that number there, which is actually really the h number. We talked about that. Here's a vertex is the negative b over 2a. That would be the x coordinate of the vertex. The y coordinate would be basically what you would plug it in. So if you find this, you can plug it into the function that's saying plug this in. This would be the input into the function where x is in both places going in. And then that would give you your y coordinate. Remember, we always have an input-output. So if we know what the x is, we can always plug that into the function and find the corresponding y coordinate for it. But remember that this right here, that x coordinate of the vertex, that whatever number that is the same number you'd use for your axis of symmetry number here. X equals that x coordinate of the vertex. And then the last one here, the y-intercept is c. So whatever this number back here is where it's going to cross the y-axis. So that's another property or characteristic we're going to know as far as standard form goes. So the point 0c is on the parabola. It's on the parabola right there. It's the y-intercept. It's where we're going to cross the y-axis. We're also going to figure out where these x-intercepts are as well. We'll figure that out in a little bit. But for now, if it's in standard form, we know that c is going to be the y-intercept. Okay, on page 32, you'll see this core concept. It's titled maximum and minimum values. And those are in the vocabulary, but you don't need to write those down because you have a core concept with these here. So it's kind of redundant to write them down over the vocabulary. But we do want to go through each of these bullet points and just understand what these are going to be, because we're going to have to, on problems, state each one of these. So as you can see, let's go quickly through these and then we'll go back through. But minimum or maximum, we have domain, range, decreasing, and increasing. So we need to say those 5 things when we're actually going to graph them. We're going to graph the parabola, but list these 5 things as well. So let's take a look through these each one at a time. So a maximum and minimum value is where, as you can see on the diagrams here, it's the highest or the lowest point of that. So it's the highest or the lowest point, which is always where the vertex is. So when it's opening up, it's going to be a minimum, and when it's opening down, that's going to be the highest point, which would be a maximum. So it's lowest here when it's opening up, highest here when it's opening down. It's the same point. It's whatever the vertex is, but we call it a minimum when it's opening up or a maximum when it's opening down. And that would always be the y-coordinate of or the y value of the vertex. So as we think about this is the vertex point, well, that vertex point is an x and a y, coordinates. It's the number for that, so our minimum value will always be the number for the y. That's what this is showing you here, f of the inputting the x, which would be the y value of the vertex. So maximum minimum value is always the y value of the vertex. Then it's going to talk about the domain of things. So our domain here is going to be really all real numbers. Yeah, that's what you could see. Why is it all real numbers? Well, from left, or where is the graph on the x-axis is always what you're asking for domain. It is everywhere. It's everywhere to the right. It's everywhere to positive infinity. It's everywhere to negative infinity. So it's going everywhere. As this window would continue to increase, this would continue to go to the right. This would continue to go to the left. It's everywhere, left to right. So we can say that it's all real numbers, but I also want to teach you another notation here, which is called interval notation. So I'm going to have you write these on the side over on this side. So instead of saying all real numbers, we can write an interval notation using the infinity symbols if it's all real numbers, because it's going to go from positive infinity to negative infinity, as I'm putting there. So our interval can just be that. An interval notation really looks like an ordered pair. So it looks like this here, with parentheses around it, positive and negative infinity, comma, positive infinity. We would always put the 1 on the left, so negative infinity is going to go always first, and then the 1 to the right. So it's kind of like a number line, right? So the smaller numbers were going to go on the left, the bigger number would always go on the right in the interval notation. On this side over here, we'll do the same thing. I'm going to put down just interval notation on this side. We're going to list them on this side as well, which would be on here, negative infinity, comma, positive infinity, all real numbers. So they both, whether it's opening up or down, is going to have that same domain. All parabolas, in fact, no matter where they're located, as long as they're opening up and down, will have a domain of all real numbers, which would be this interval notation with the infinities. But now, okay, the range. The range would be the question of where is the graph on the y-axis. Obviously, that's not everywhere. We can see that on this one, it's not above this minimum, or sorry, it is only above this minimum point. It's not below the minimum point. This one's not above the maximum point. It's only below that. So our range is not going to be all real numbers. It's not going to be this interval notation, but we still can use an interval notation now. And remember, the range is, as you can see, it's the same thing as the minimum value. It's that same number. You're going to use that same number again for the range. It is the y value of the vertex. So whatever that y value of the vertex is a number you're going to use. Now you can make an inequality out of it. You can make it like this, where y is greater than or equal to that number of the y value of the vertex, or in this one, because it's opening down, y is less than or equal to that number of the maximum value number. Or as an interval notation, it would look like this. For this one over here, where y is greater than or equal to that number, we're going to state it as, because it's above it, we're going to say that the y is above, so it's going to go from wherever this y is to positive infinity. So the smaller number is going to be the minimum value number, the y number here, and then the bigger one would be obviously infinity. So it's going to go y first, then infinity. Notice I did put a bracket around here. We do that because it's going to stop at that number. So it's not going to be, it actually does include that number is what that really means. It does include that number. If it wasn't going to include that number, then we put a parenthesis. That's the interval notation rule. So the bracket means it does include this number here. A parenthesis would say it doesn't include that number. With infinities, we always just put parentheses because obviously infinity just keeps going forever. It doesn't have really a stopping number then. On this side over here, because it's less than, or it's, you have your y and then it goes down, it's y is less than that number. So that means that negative infinity is going to go first this time, because this is coming up from negative infinity. It's going to go down towards negative infinity, and it's going to stop at that y number. So that's again why we put the bracket there. So again, those are just interval notations, an easier way maybe to state the domain range, or you can continue to state it with all real numbers or with the inequality. The increasing and decreasing now, these kind of all go together. As you can see, they all say x equals here. So for these ones, it's always going to be the x coordinate of the vertex, or the x value of the vertex. Where everything else has been the y value so far, these, the increasing, decreasing, is the x value. So as you think about, okay, what are we talking about with that? Well, you start from the left and you kind of usually go to the right. So this arrow right here is as far as left as we could see. So what's happening first, as it comes in from negative infinity, it is going to be decreasing first, and then after this it's going to be increasing. After the minimum value, it's increasing. So it says, it's decreasing to the left of this, x number of the vertex here. So from the left, on the left side, it's decreasing. On the right side, it's increasing. So increasing to the right of that number. This one is doing the opposite. It's coming up first. So to the left of the maximum number, the x coordinate number, it is increasing. And then after it passes that, on the right side, it's decreasing. So that's why it's saying that. It's saying it's kind of the opposite direction. So we're going to have to be stating these as we kind of go through. Hopefully we'll get the hang of that as we're doing that. Okay, so on page 33, we start our extra practice with these three problems here. It says to graph the function. We're going to be also labeling the vertex and axis of symmetry, also finding the minimum or maximum value of the function, also describing the domain and range of the function, and last thing, where the function is increasing and decreasing. So a lot to do on each of these problems. The first thing would be probably the hardest, maybe, would to graph it and then go off of all these other ones. Now you want to keep looking back and referring to those core concepts that we just went over to help you do this part. But as far as graphing the functions, we notice that the equations of number 1 and 2, our functions, are in vertex form. Both of those are in vertex form, so it's just like 2.1's lesson that we just did, in the last lesson, where we can find the vertex very quickly and then look for some points after that. We need about 5 points to create our parabola. But the number 3 problem, as you look at this one will be standard form. So we have to remember what we just talked about with the core concept there about standard form, and really kind of how to graph this. How do we find the vertex when it's in standard form? All right, so let's just go to number 1. Let's go ahead and find this vertex. It's always your starting point. That's where you start from. So where do I begin even to start to graph this? Well, you start with your starting point, which is the vertex. So we need to know that first. And what would that be? Well, that's always your h comma k when it's in vertex form. And the number inside is always h. The number outside, that's either adding or subtracting to the parenthesis or to the squared function part, is your x or is your y coordinate. It's the k number. So as we can see, we do have a number inside here. It's positive 1. It says x plus 1. But remember that the h number really kind of is the opposite of that, because it's always the number that would make this inside here equal 0. So negative 1 is really h. And since there is no number back here, 0 would be the k. So our vertex is just negative 1 comma 0. We can just identify that from looking at the vertex form. That's why we call it vertex forms, because you can identify the vertex. Go ahead and plot that point right here on your coordinate plane. Every box here will say is just worth 1, so this would be -1, 0 right on this x-axis. And now we'll notice that there is no a number, which doesn't change the shape. The shape is still the same as the parent graph. It also, we want to notice that it's positive here in front of this, so that means it's still opening up. It is opening up just like the parent graph does as well. So if it has the same shape as the parent graph, we know it's opening up. We can go off that parent graph pattern that I was teaching you in the last lesson, where all we do starting off is going 1 to the right, and then we're going to square that number. We go 1 up, right? 1 squared would be 1. So we can go 1 to the right and 1 up and put a point. We can do the same thing, go 1 to the left and 1 up from that vertex. And then we go back to the vertex point and we'll go 2 to the right from the vertex. And then we will square that number. 2 squared is 4, which means we're going to go all the way up to here to 4. And then we do the same thing, 2 to the left, and we can also go with the same number, 4 up there. So that gives us the number of points that we need. All we need to do now is just graph this parabola. It's a U shape. Make sure you graph a U shape. X squared functions, quadratics are always the parabolas, the U-shaped functions. Okay, so now we need to do all this other stuff. It says label the vertex. That shouldn't be hard. Your vertex, we already know, is this point here, so we can just tack a little label on it. It also says to label the axis of symmetry. Now remember, the axis of symmetry is a vertical line that goes straight through that vertex point. And so we're going to put a dashed line. I'm going to do that so that way you remember you're going to put a dashed line as well. You don't want it to distract you from the actual graph of this, but you just want to put a light dashed line right through there, vertical line going down, and we're going to label that x equals -1, because remember, this x coordinate here is the same number you're going to use for the axis of symmetry number. Those are going to be the same number, -1. And then the next part, it says find the minimum or maximum value. Well, since it is opening up, the vertex would be at the bottom, which would be a minimum. So we want to say the minimum is equal to, and it's always the y coordinate, which would be 0 on this one. I'm going to just abbreviate it, min. So the minimum equals 0. That's all you have to do for that part, is just identify that, and it's always the y coordinate of your vertex number. The next one says to describe domain and range. Okay, well, we do know every time we have a parabola, it's opening up or down, which is what all of these are going to be. It's going to be all real numbers. So we could say domain is all real numbers, but I'm going to write this in all of these in interval notation. That's why I was teaching you that earlier, and that way you get used to seeing interval notation as well. So the domain I'm going to say is from -infinity to +infinity. It's the same thing as saying all real numbers. The range for this one, now the range is only going to be above this vertex right here, so it's only above 0. So that means that it's going to start off at 0, and then it's going to go to +infinity. That would be our range. So it's going to be 0, +infinity in the interval notation. We would put a bracket around here because it is touching 0. If you wanted to make an inequality out of that as well, the other way you could write this is just y is greater than or equal to 0. So these are two different ways you can write the range. The next one says, also describe where the function is increasing and decreasing. Now remember, if it's opening up here, it's going to be decreasing first. So it's decreasing from the left of this vertex number, which would be from x equals this, axis of symmetry, -1. So to the left of -1, it is decreasing. It's going down. To the right, it is increasing. I'm going to put that as a interval notation as well. We can do that as well. So if this one is decreasing, it's starting off at -infinity and coming down to -1. And then it's increasing. So where is it increasing? It is increasing from -1 up to +infinity. So it's not necessarily +infinity going up this way where this arrow is. It's really this arrow over here. So really we need to see these as our infinity symbols on this side. You may want to put -infinity over here and +infinity on this side to remind yourself that as it comes in this direction from the left of this line, it is decreasing, it's coming down. So from this infinity to this number, -1, and then from this number, -1, going out towards +infinity, it is going up, it's increasing. So that's what's going on. Number 2, another vertex form, so we can identify our vertex first. It's our starting point. One thing I do want you to do first, though, I just did that, is make sure that you see this -5. I want to change that to +5 because if we do it with a -5, it really kind of makes the graph window a little weird. So I think it really should have been meant for +5. So change that just to a +5 there. That would be our K number, would be 5. So the H number for the vertex, we want to find that. That's going to be just right in here. So +4 would make this equal 0, or you can just think it's the opposite of that there. It's +4, +5 now as we change this. So 4, 5 is going to be our vertex. We can plot that point on our graph right here. So we can say, 4 and then going up 5. Now the reason why I did change it is because if I did that, it would have been 4, -5. And look at what would happen here. It's going to go down. And so really the graph is going to be way down here. And I just didn't think that was, something we wanted to do. So let's go ahead and put the 4 or 5 up here. So that way when it goes down, it is opening down, it'll stay kind of in our window. Now the next thing we want to do here is get these other points. Now since this one does have a 2 in front, it's not going to be the same shape. In fact, because that 2 is more than 1, it would actually be going narrower, a thinner graph than this one over here. So what we could do is just a table of values. So we could just do a little quick table of values, x and y. We can pick a number for x to be. Let's go ahead and just pick 3. Now I'm picking 3 because my vertex is at 4. So I'm going to go this way 1 and pick 3 for x and see, okay, where is it going to be? Just right next to the vertex point. We want that to be our middle point. And everything we do that's on this side is going to match on the other side as well. So as I put in 3 here, I just want to, let's just do this mentally. 3 minus 4, that's going to give me -1 in the parenthesis. -1 squared would be +1. And then +1 now times -2, that's going to be still -2 there. So -2 now, this whole thing now is just a -2. -2 plus 5. Well, that's going to be 3 as well. So 3 is another point, and we could put that on our graph. But we're going to match that point on the other side. So if I go 1 this direction, I'm also going to go down 2. So that's going to put a point there because these are all symmetrical. We do have an axis of symmetry being our vertex right there. Now if I go 1 more point, which would go now from 3 to 2, so I could try 2 next for x. Plug in 2. Where is this next one going to be on the 2, where an x equals 2? Let's go ahead and do this mentally again. If I put 2 in here, 2 minus 4 is going to be -4. And then 2 minus 4 is going to be -2. Then -2 squared is +4. And then +4 times -2 is -8. So this whole thing here is -8. And then we're going to add 5 to it. -8 plus 5 is going to give us -3. So 2, -3. So when we're at 2, we're actually going to go down here to -3. So we're way down there. And so if that went 2 this direction, we went all the way down to -3. If I go 2 this direction, I'm going to go, it's just going to be off the graph a little bit. We're going to be out here, down at -3. So let's put a point out there. And now that gives us enough points to be able to graph it. Let's go ahead and draw our parabola. Make sure it is a U shape. And it is a little narrower than the one over here, which it should be. And then we just do all the rest of the stuff that we're supposed to do. Label the vertex. Again, that's easy to do. Just slap a label there. Also label the axis of symmetry. So again, we're going to draw a line through. That dashed line goes right through. Vertical line going through it. And also label it as x equals 4. It's the same number as your vertex x coordinate there. The next thing we're doing is finding maximum or minimum. Well, since this is opening down, this will be a max this time, and the number for that one will be the y-coordinate there, 5. So it's going to have a max equals 5. Our maximum is 5. And then it says to describe the domain and range. Well, because it is opening down, it's the same as opening up. It's all real numbers, so the domain there is going to be the same thing. The interval notation would be -infinity to +infinity, or you could just say all real numbers. For the range, that'll be a little different than this one. The range is always based off of your y number here, so 5. So this is only going to be 5 or below, so it's going to go towards -infinity. So we're going to start it at 5 and then go to -infinity. So it's or negative infinity comma 5, I should say, because negative infinity obviously is less than 5. You always want to put the one that's smaller here. So since 5 is greater than negative infinity, we're going to put the 5 second. Just like we did here, the 0 was smaller than the positive infinity. So it's going to start from negative infinity and then stop at 5. That's where it stops right there, and we're going to put a bracket there to show it also equals 5. We can write this inequality as well. Now sometimes the inequality might just be easier to say, and that's fine. You can write it either way, but I'm trying to show you what interval notation is. That way you know what it is when you see it. So you're not confused when you look at this notation and think that this might be some kind of ordered pair or something, or some weird ordered pair. It's not. It's just a notation from negative infinity to 5. So you could also say just y is less than or equal to 5. The last one was the, where is it increasing or decreasing? So again, that's going to go from our x-axis here. So you're starting off over here at negative infinity. What's it doing from this side until we get to the axis of symmetry? Well, it's going up, right? It's going up towards the vertex, just like a roller coaster. It's going up the starting point, and then it turns, and then it goes down, right? So it's increasing first. So it's going to be increasing first from negative infinity to this number 4, to the number of the axis of symmetry number. And then after that, so on the right side of this x equals 4, what's it doing? It's going down. So it's decreasing from 4 to positive infinity. Okay. Now a lot of times it does say, it's increasing on the left of x equals 4, to the left of x equals 4. It's decreasing to the right of x equals 4. That's another way they say it. All right, let's go on to the standard form one. This will be a little bit different. So again, what is the same is we do need to figure out what the vertex is first. So to find the vertex, at least as far as the x-coordinate goes, is we need to do this little formula, negative b over 2a. That's a little formula for standard form to be able to find the x-coordinate of the vertex. So we got to plug that in. Now remember, a would be this 3 over 2, b is negative 3, this negative 1 would be c, so it's like ABC. So as we put this in, you're going to say, okay, negative b. Well, b is negative 3. Well, the opposite of that would be positive 3. So we're going to see 3 on the top, and then 2 times 3 over 2 on the bottom. And we're going to be able to cross-cancel those 2's, and now all we would have would be 3 over 3, which is equal to 1. So x on the x-coordinate equals 1, so we could start off our vertex as 1, comma, and then we got to figure out what the y-coordinate is. So we can't see the y-coordinate. In fact, in order to find the y-coordinate, what we have to do is take the 1 and use that as an input for the x in both places here. So we got to plug 1 in for x in both places, and then just solve this and figure out what the y would be. Because remember, t of x is a notation that means y. So y equals this when we plug in number for x. So when we do that, it's going to be, this will be 1 squared, and then 1 times 3 over 2 is 3 over 2. Negative 3 times 1 is still negative 3, and then the negative 1 in the back here. So these two would make negative 4, so it's 3 over 2 minus 4. Now 3 over 2 is the same thing as 1.5. So if I take 1.5 away from 4, that's going to give me negative 2.5. That's the y-coordinate for the vertex. So now where is that going to be? Everything's worth 1 here. We go 1 to the right, and then 2.5 up. We're going to be right about in that spot. I'm sorry, not up. I messed up. That's negative. So yeah, this way, and then we go down 2.5. My bad. So we're down here for the vertex, and we want to notice, okay, is this going to open up or down? Because that will help us determine where our points are going to be. Since the a number is positive 3 over 2, we know it's going to open up. So our points, as we kind of go left and right, 1 from each of these, we're going to be starting to see it's going to be going up there. And to do that, we can do a little table of values again, which is a good idea. If this was just x squared, if it didn't have 3 over 2 here, if it was just a 1x squared, well then it would have the same shape as the parent graph, and we could do our parent graph pattern on this one like we did on number 1. But since it does have a 3 over 2, that's going to change things. Again, it's going to be a little narrower since that's a little more than 1. So our graph we'll find is a little bit narrower. Not quite as narrow as this one though, because this one had 2. So as we plug in numbers, let's first figure out the 0. That one's going to be easy, and the reason why that one's easy is because when x is 0, that's a y-intercept, which is what this c number always is. Remember, that was one of the characteristics we saw in the core concept, that the y-intercept is always this number here. So we can just say, okay, when I have 0, I know if I want to plug in 0, that's just going to be -1. So that's an easy point to find. And so we can plot that point here at 0, -1. So that went 1 to the right of this vertex and went 1.5 up. We can do the same thing on this side. Go 1 this direction and 1.5 up and put a point there as well. Because remember, symmetry. This is symmetrical. Whatever we do on the left side is going to do the same thing on the right side, or vice versa. Now, if we go one more, if I go to -1, we can plug that in for x. If I plug in -1 for x, let's go ahead and just kind of think of this maybe mentally. Actually, I'm going to do it, but we'll kind of put it over here. If I put -1 here, -1 squared is going to be +1. So that's going to make this just still 3/2. If I put -1 here, that's going to make that a +3. So it'll look like this. So it'll be +3/2 from this first term, because this is going to be -1 squared. Negative times negative is positive. So that's now just 1 times 3/2, which is now there. -3 times -1 is now +3, and we still have the -1 in the back. So if I take 1 away from 3, that's going to make this into a 2. So 3/2 plus 2. So that's 1.5 plus 2, which is going to be 3.5. So if you go to -1, we're going to go up to 3.5. It's going to put us right about in this area here. So go ahead and put, whoops, messed up. There we go. So go ahead and put this right here on your graph, and then the same thing on the other side. We're going to go ahead and go 2 this way and go all the way up to the same level as what we're on here, which would be 3.5. So go ahead and do that as well. Now we have our points. We can graph it. Go ahead and graph your parabola. Draw your U shape. It is a little thinner than the parent graph pattern that was this one, but it's not as thin as this next one here, because this was 1.5, this was 2. Now we need to do all our other things, which is label that vertex. Go ahead and slap the label on it. Label your axis of symmetry. Draw your dashed line. Label it as x equals 1, which is the same number as the x coordinate of the vertex. We're going to find our maximum or minimum. Now this one, since the vertex is at the bottom, is a minimum like this was over here. That's going to be also the same number as the y number of the vertex. So it's going to be a minimum is equal to -2.5. We're going to see our domain is the same thing. It's all real numbers, or that -infinity, +infinity of interval notation. Our range here for this one, to figure that out, we know it's going to be using the number right here, this -2.5 number. Range is always about the y number, so of the vertex, and it's going to be above. So it's and we could say that y is greater than or equal to this -2.5 number. Interval notation would start off with the -2.5 first, then going to +infinity because it's going up. But we could write it as that inequality as well. Y is greater than or equal to -2.5. The increasing, decreasing part. So start over here on the left, on this left arrow. As it's coming in this direction from -infinity to your x equals 1, what's it doing? Well, it's going down. So it's decreasing first. So it's going to decrease from -infinity to 1, or that would be to the left of the x equals 1. It's decreasing to the left. And then it's increasing from 1 to +infinity. So from 1 to +infinity is going up. It's increasing. Alright, so that is just where we have to use all these characteristics and label everything and describe everything. We're going to move on to the next form here, but before we do, let's do a little joke of our day. So, joke of the day, what has 2 legs but can't walk? 2 legs but can't walk. Well, it's a pair of pants, silly. Pair of pants, of course. Okay, so our next form, this would be on your vocabulary, back at page 32. Intercept form is the third and final form of our quadratic functions that we could be graphing. So we graph vertex form, we graph standard form, and now we're going to be graphing intercept form. So write this down here for intercept form. F of x equals a. That a number is still the same a number as we've seen before. And then the parenthesis x minus p, parenthesis x minus q. So let's see, okay, what is this P and Q here talking about? So this would be if like we were to factor this, if you were to factor, and you should have learned factoring in Algebra 1, but if you were to factor your trinomial, the standard form function of a quadratic usually is a trinomial, if you were to factor that, it would end up being these factors here, which is the intercept form, and from those factors we could actually see the x-intercepts, which are always the solutions to a quadratic equation. So that's what we're looking for, is the P and the Q numbers are where you're going to see these x-intercept numbers being, right there. So that's where you can just look at this form. If it's in this intercept form, you'll notice the P and Q numbers are where it's going to cross through the x-axis. Those are your x-intercepts. But now we can't just graph it using those. We need at least the vertex always. So we still have to figure out the vertex point. We might be able to start with our x-intercepts, but we're going to need to use those x-intercepts to find the vertex point, which is going to be our maximum or minimum point. To do that, we want to do this. You might want to highlight this right here. How do you find the x-coordinate of the vertex? Well, you're going to do P plus Q divided by 2. That's a little formula for the intercept form. So whatever numbers P and Q are, you add those together, divided by 2. That gives you the x-coordinate of the vertex. And then you just use that number, plug it back into x in both places in here to figure out what your y-coordinate would be. Okay, once you know that, now you'll know your vertex point, you'll know your x-intercepts. You may want to figure out maybe a couple more points here as well. As you plug that, as you go up, further up, you might need a couple more points using a table of values to find that. But as far as everything else, it's the same. The A value helps you figure out if it's going to open up or down. If that's positive for A, it's going to open up. If it's negative, it's opening down. That's still the same characteristic there. Axis of symmetry is always still going to be right there through your vertex point. So once you figure out that vertex, that's the P number is still going to be at there. All right, so let's move on to doing a couple problems using intercept form. Okay, so back on 33, number 4 and 5 of our extra practice, it says to graph the function, and we're going to do just a few things here. Label the x-intercepts, vertex, and axis of symmetry. So not as many things as we were to do before. Now we could still do all those other things, but it just wants us to do these 3. So first of all, this is in intercept form. We'll notice that. See your intercept form, your A number here, and then you have 2 parentheses where x is split. So it's not, you don't see any exponents of squares anywhere. Nothing's squared. A binomial is not being squared. X is not being squared because there's 2 x's. You can see them both here. So x is split into 2 factors basically. X plus 4, x minus 3. That's our intercept form. Same thing over here. There's 2 x's being split. The x is out here with the A number. And then that means there's just, there's nothing there. There was like x plus 0 here, or x minus 0 on this one. And this one has 6 with it, x minus 6. So as we first look at this one, we could start with the intercept since it is an intercept form. So we can start trying to find, okay, what are the 2 x-intercepts here? And for that would be the opposite really of what these are. So remember, it's going to be, what would make this 0? Well, negative 4 would make it 0 here, positive 3 would make it 0 here. Now remember, x-intercepts is when y is 0. So it's going to be negative 4 comma 0 for this one here, because remember it's the opposite of what you see. And then it's 3 comma 0 for this one here, because 3 minus 3 would be 0. And then we want to now find the vertex. So using these numbers here, and we're using these 2 numbers, the negative 4 and the 3, that would be the P and the Q numbers as we looked at that core concept. So we take the P and Q numbers, we add them together, and then divide by 2. That will help us find just the x-coordinate of the vertex. So negative 4 plus 3, that would give us negative 1. So negative 1 over 2 is just a negative 1/2. That is the x-coordinate of our vertex, a negative 1/2. Now to find the y-coordinate, we would need to plug this in both places here. So we would start off by saying, I'm just going to change the f of x to a y and just say y equals, starting off with 4. And then the first parenthesis says x plus 4, so we're going to put negative 1/2 plus 4. Second parenthesis, we're going to put negative 1/2 minus 3. And so now we'll still keep that 4 there, but now we're going to just do what's inside these parentheses. Take a half away from 4. That's going to be 3.5. This one, they're both negative, so you're going to have to add it up. Basically, add a half to 3. That's also 3.5, but it's negative 3.5. So now as you add this up, you only have one negative in this, so it will remain negative. You'll have a negative y coordinate here. 4 times 3.5 times another 3.5. We can do that on a calculator. That becomes 49. So our y is negative 49. So that completes our vertex. So at this point, we could just, plot these points. We can plot our vertex. Now I'm going to go by ones here. Actually, no, I'm sorry, I'm not going to go by ones. I'm going to go by tens. Obviously, I couldn't go by ones, otherwise I would never get to negative 49. So basically, if you can pretend that each box here is worth 10 units. So this is negative 10 all the way down to negative 50 here at the bottom. So negative 49 would just be right above that, right at negative 1/2. Well, negative 1/2 is going to be just slightly to the left of our y-axis there. So we're right down, kind of right in this area here. So let's put a point down there for the vertex. So right in that area there. And then for the x-intercepts, these two, we can put these on here. Negative 4, 0. Now, again, let's go by as well with this. Just make this tens as well. So if this is 10, negative 4 is not quite halfway. So it's a little bit less than halfway there. And then positive 3 is even less than halfway. It's going to be even closer to the y-axis on the other side. Now, we can just stop right there and try to graph our parabola. Just do your best at graphing that. I'm not going to require you to get any more points. You don't need to do any more table of values. You just need to be able to graph it from that. We know it's opening up here. The A is positive 4, so we know it was opening up. Our points are showing us that it's opening up. So you just need to graph a very thin parabola. And try to make it a U shape, not a V shape. Okay, down here, trying to do a little bit of a curve down at the bottom. And then we're just going to go ahead and do these things, label the x-intercepts. So let's just go ahead and slap a label on these. Just the label is going to be their ordered pairs. You're going to label them with the ordered pairs. So negative 4, 0 on that side, positive 3, 0 on the other side for that point. Label the vertex, and we're going to label it not just with a name vertex. Let's go ahead and label it with also the ordered pair. Negative 1/2, comma negative 49 down there. That's the vertex. And the axis of symmetry, we're going to go ahead and just draw a line. It's not quite on the y-axis, but it will look like it's almost on the y-axis, just a little bit to the left of that. It will be x equals negative 1/2. That's the equation for that. And then draw your dashed line just right next to going through that vertex point. And that's all we need to do. Number 5 now, on this one, we can identify the x-intercepts. So this one here, remember I said this would be like x plus 0. So this one has no p number. There's your q number, which would be the opposite of what you see, which would be 6. So identifying your x-intercepts, we're going to see the first one is just 0, 0. Now your x-intercept y is going to always be 0 on these because you're looking for where it crosses the x-axis here, which is when y is 0. But this one doesn't have a parenthesis for this first x, so that means your x is 0 as well. Since this one does have a parenthesis, your x number is going to be this number here, which is really the opposite of what negative 6 looks like. Positive 6 minus 0 would make this 0. So you're always trying to figure out what would make this 0 here. So 6, 0 is the other x-intercept. Those are the two x-intercepts we have. And then as far as the vertex, we're going to go ahead and just take these numbers, 0 and 6, add them together. So x-intercept will be 0 plus 6, or not the x-intercept, the x-coordinate for the vertex will be 0 plus 6 divided by 2. That's how you find the x-coordinate for the vertex when it's in intercept form. When it's in vertex form, we can just read the h and the k, and that gives us our vertex. When it's in standard form, then we have to do a formula for finding the x-coordinate there, which was the negative b over 2a. And on that one and on this one, we need to now take this number that we find, which in this case will be 6 over 2, which is 3. So we're going to take this number 3 now, the x-coordinate of the vertex, and plug that in both places here, and then find the y-coordinate. So it starts off negative 7, And I'm gonna put this in parentheses so it's gonna go in right there. There's gonna be a 3 going in there and a 3 going in here. So it's gonna be y is equal to -7 and then times 3 and then times 3 minus -6, which is times -3. So as we multiply all of this together, that's going to be basically 6 times 7, which is 42. Or sorry, not 42, sorry, 9. I know that's 6, I'm adding together. 3 times 3 is 9. So 9 times 7 is 63. So we're going to see 3 times 3, which would be like 3 times -3 really, would be -9, -9 times -7, giving us positive 63. So that's our y-coordinate for the vertex. We could go ahead and plot that point, but again, I need to kind of number this in a way that's going to make, 63 on this graph. If I do it by tens again, that makes this 50 right here, which means 60 is a little bit higher, 63 is even higher than that. So if we go tens every way again, and let's just do that, 3 is going to be not quite halfway over this way, and then you're going to go all the way up past 50, 60, and then 63 is going to be right up in this area. So the first thing I did actually is I put the intercepts down on this one. So I plotted the intercepts first. So 0, 0 is there, 6, 0 is next to it here, not quite to 10 of course, a little bit past halfway, and then our vertex, there it is up there. So it's going to be right in the middle of these two. Remember, your vertex is always going to be smack dab in the middle between the two x-intercepts. So straight up to, there's 50, 60 would be about another box higher than that, 63 is even higher than that. And just again, go ahead and graph your very, very thin and narrow graph here, because we made this window going by tens. And so just try to make it a curve up here at the vertex, so it's not a V, it's a U shape. And then let's just go ahead and label the x-intercepts with the coordinates. So you got 0, 0 on the one side, 6, 0 on the other side. I'm not going to do anything with the vertex. That's kind of already labeled up there. There's the vertex there. It's kind of already been labeled. And then just axis of symmetry. So right down through, it's going to be x equals to 3, which is straight down the middle. Do a little dashed line straight down the middle. Alright, so that's completing 4 and 5. We have just one more to do, which is kind of more of a real life problem. So let's go into that one. Okay, so number 6, this real life problem, it's a softball problem. So a softball player hits a ball whose path is modeled by this quadratic standard form equation. It's got some decimals in there, but it's still just a standard form quadratic equation, where x is the distance from home plate in feet and y is the height of the ball above the ground. So now here's our questions. So what is the highest point this ball will reach? That's the first question we want to answer. And the second one, it says, if the ball was hit to center field, which has an 8-foot fence located 410 feet from home plate, was this hit a home run? And then it wants us to explain our kind of yes or no answer on that. So, but the first thing it asks us is just, what is the highest point? So the highest point, now obviously if it's a softball, we know this is going to be going up in the air. It's a parabola shape where it's going to be opening down. So it's going to have a maximum point. Our highest point will be that maximum point, which is the y-coordinate of the vertex. So all we have to do is find the vertex, and we answered that first question. So the first thing to find the vertex is making sure we know what A, B, and C are here. So we know this is our A number, our B number, and C number, and we're going to use that to plug it into this little formula for finding the x-coordinate, negative b over 2a. So as we plug in the negative b, so it's going to be the opposite of this number times 2 times this first number. So negative times b, and then 2 times a. And then we just got to do 2 times a down here, so that's going to give us the, again, negative b times this now negative 0.001. And so on a calculator, you're just doing all of this on the calculator. Now I multiplied this probably on the calculator here even, but you could have done that in your head. But at this point, I'd probably multiply on the calculator. We can see definitely it is a positive number, which should make sense because it's going to be going out further. And then as this number divided by 0.001, I mean, we could just move the decimal back really 3 places, and that would make that 212.7. So that is really how far this ball is being hit. 212.7 feet. So in this case, we have the x coordinate now going to go into our function. So we're going to plug the x in now to our function. So x is going to go in there in both places, starting off with our first a term. So it's the a times the 212.7 squared. That's what we're going to put here. Then plus this b number times that 212.7 number, and then plus the 3 at the end. So now as we work these out, I mean, we can do this on a calculator. You can go ahead and plug this in a calculator. I'm going to first multiply this by itself, or 212.7 squared, and then times it by this negative 0.0005. And that's going to give me this number of negative 22.62. You can go ahead and check that on a calculator. This one, go ahead and multiply these two numbers together. That's going to be plus 45.24, and then the plus 3 in the back. So now when I add these up, I'm actually going to add these two positive ones and then take the negative one away from that. So it makes it a positive number, positive 25.62. So that would be the maximum value. That's answering our question of the highest point. So the maximum value is 25.62 feet. Now the next question, if the ball was hit to center field, which has an 8-foot fence located 410 feet from home plate, was the hit a home run? So basically, if it was hit 410 feet using this equation, we would need to plug in 410. Remember, that's the distance from home plate. This one here, when we actually figured out what the vertex was, what the highest point was, right? Our highest point is at a distance of 212 feet. Now we could do this, I guess, a couple different ways. We could see, well, if I say this times 2, right? Because remember, the vertex is right in the middle of where the x-intercepts would be. So one x-intercept would be at home plate, which would be like 0, 0. The other x-intercept is where is it going to land on the grass. So that means if I say, okay, add times this by 2, that's going to be 425 feet. Well, that is further than 410 feet. But the question is will it hit the wall and not go over the fence, or will it be higher than the 8-foot fence and go over? So we need to figure out at 410 feet, because we know it's supposed to hit the ground at 425. Well, how high is it going to be at 410? If it's higher than 8 feet, then we know it's a home run. But if it's not higher than 8 feet, then it wouldn't be. So let's go ahead and plug in 410, just like we did here with the 212.7. So we're going to plug in 410 now. So our A number times 410 squared. And then the B number times 410 plus the 3. And then again, the calculator, all of this, 410 squared first, so multiply 410 times itself, then times this decimal in front. That gives us a negative 84.5. Then you multiply this decimal times 410, that gives you positive 87.21, and then the plus 3. And then it can add these two together. That makes it 90.21 here. Take 84.505 away from that. That gives you a 6.15. So that would be the height of the ball at 410 feet, which means since it's not more than 8 feet, it's not going to be a home run. It's going to hit the fence. So the answer for this one is no, not a homer, because 6.157 is less than 8. So it's going to hit the fence instead. Alright, so that concludes our lesson here on 2.2. And you want to go on to the assignment for this lesson, and I'll see you on the next video.